Let me guess, you know all the SAT math rules and formulas, but there are still some questions in Module 2 that stump you. That's because the SAT isn't just testing your knowledge, it's also testing your critical thinking skills. In this video, I'll be going over 5 of the hardest SAT math questions that most of my students miss. And these questions are from Blue Book practice exams, so this is your one and only spoiler alert. And here's our first question. Pretty upsetting looking, right? And most of my private tutoring students felt the same way. They're like, Robert, what the heck am I supposed to do here? Why don't you pause the video and try this one on your own first? In fact, I think you should pause the video and try all of these on your own first because it's good practice. But let's talk about what's going on here. So this is actually a really easy question once you know what it's asking. It's just the language here is kind of confusing. Basically, it's saying for each real number R. So when it says that, it is telling us that R represents every single real number. A real number being a number that's not imaginary. And that's something that you would learn about in Algebra 2. But basically, R should work as every single number. And then from here, with that in mind, I'll kind of show you how we can test our answers and pretty quickly get the correct one. So we are going to utilize Desmos. And the first thing you're going to want to do is put in your equations. And here, it's interesting. We're going to notice, I mean, if you didn't see already, we're basically multiplying the first equation by 4. So they are the same equation. So the whole fact that it's a system is just like a red herring. It doesn't matter. And then what we do to test our points is we can literally just put in an answer choice. So let's put in the first one, choice A, and we'll write it exactly as it's written on the page. All right, is that looking good? That's looking good. And then we're going to add a slider R. And this is a point, right? Now remember, it says R represents every real number. So I should be able to slide R around, and no matter where I slide R, it should end up on the line. So we can see here that that is not the case, right? It's not ending up on the line like we want it to. So we know that that is not our answer. So choice A is not going to work here. Let's change it to choice B, 5/6. It's not on the line, so that's not going to work. If we do R over 4 plus 5, negative R over 4 plus 20, that's not on the line. So it must be choice D. And then finally, if I put in choice D, you can see it's on the line. And then as I move it around, it stays on the line. So that's what it means by R is every real number. Like I can literally back up. I can make R, whatever. So yeah, that's how we get choice D as our answer. All right, pause the video and try this one on your own first. But here we go. So for this one, kind of like the last one, although not to the same degree, half the battle is figuring out what it's being asked and what kind of equation we're dealing with. And this is going to be a system of equations written in standard form. And a good place to start with this is the combining two pieces. So it says the first piece was 30% silicone by mass, and the second piece was 80% silicone by mass. So we have two different pieces with two different values. That should tell you we're dealing with systems of equations. And you do want to write this in standard form. So normally it'd be like, AX plus BY equals C, where A and B are going to be values. So my values in this case are going to be 30%. We could say that's 0.3. We'll change it to an actual number. And we'll stick with X and Y for now, plus 0.8Y equals our total. Now, our total, according to the first sentence there, is going to be a total mass of 50 grams, and it's going to be 50% silicone by mass. So it would be 0.5, because remember, our percentage is the value that we are attaching to X and Y. And here we actually have, 50 grams, right? So it'd be 0.5 times 50. So what we're missing here is the actual amount of grams. And what we do know for sure is that our second equation would be basically X plus Y, X being total grams of the first one, Y being total grams of the second one, is going to equal the total number of grams, which it tells us is 50. So now you can see we do have two equations, a system of equations, and from here we can proceed as we would with any other system of equations. So I'm just going to throw this into Desmos. All right, now we've got our solution here. So we know our solution is going to be 30 and 20. And just remember that that's going to be 30 grams of the first one and 20 grams of the second one, basically. Okay, now here's where things get tricky. And a lot of my students actually set this up properly, but then they get the wrong answer because it says, what was the mass in grams of the silicone in the second piece? And like we just said, we know that the total mass of the second piece was 20, right? Because we chose the second piece to be designated as Y. Here's the issue. It's not asking us about the total mass. It's asking about the mass of the silicone. So we only want the mass of the silicone, which means we need to take that 20 and multiply it by 80%. So final step here would be 20, our total mass, but only 80% of that because that's what it's asking about, just the silicone. So our answer is actually choice B, 16, not choice C, 20. So that's what makes that one so tricky. All right, next one. Go ahead and pause the video and try this one on your own first. But here we go. Any word problem, I always like to start with the last sentence so I know what it is I'm trying to figure out. And it's saying, what is the probability of selecting a maple tree? So probability is always desired divided by total. Desired being what you want, in this case, maple, divided by our total, which is the population that they're giving us. And it says, given, the word given means this is our population, that the tree is 20 feet or taller. So I'm going to say 20 feet plus. Okay, and this is just a placeholder, right? Let's find out what these actual values are. And since our desired is going to have to come out of our population, let's figure out what our population is first. Let's figure out how many trees in total are 20 feet or taller. So it tells us that we have 6 rows of birch and 5 rows of maple. So I'm just going to put a 6 and a 5 here. And then each birch tree has 8 trees 20 feet or taller. Okay, so the birch would be 6 times 8. And then I don't care about the shorter ones. Each row of maple trees has 9 trees 20 feet or taller. So that's going to be 5 times 9. And that's all of our trees that are 5 feet or taller. So our denominator in this case is going to be 6 times 8 plus 5 times 9. And we'll worry about letting Desmos do that in a second. And then finally, let's look at our numerator, which is all the maple trees that are 20 feet or taller, right? So basically, we already wrote it down. All the maple trees that are going to be 20 feet or taller would be the second thing, right? The 5 times 9. And let's just throw that into Desmos real quick. Throw that into Desmos, and all of our answers are obviously fractions, so click your fraction button, and we get 15 out of 31, which is choice C, and which is our correct answer. And in case you're wondering, if you don't do things right, if you get your population wrong or your desired wrong, some of these other answers are either going to be exactly what you get or it's going to be close to them. So that's what makes this so tricky. I think the thing that's tricked most of my students specifically is the word given. They don't recognize that given applies to the population, aka the denominator, not just the numerator. So be careful of that word given for probability. All right, pause the video and try this one on your own first. But here we go. So I want to show you 2 routes. I'll show you a really easy way to use Desmos, but then I'll also just show you the more old school way, and in which case we'll still kind of use Desmos. But basically, I like to turn words into math here. So we have positive number A is means equals. This I'm going to change to a number. So that would be the number version of 2,241%. Of means multiplied by. The sum means plus B and C. So that's one equation that they're giving us. And B, remember is equals 83% of 0.83 of C. What percent of B is A? So basically we have a little system of equations and it's asking us what percent of B is A. So basically if we isolated A, it would equal something B, and that number would give us a percent. So really, we would just want to use substitution. So since we don't have an equation that has just A and B, we can substitute C by moving this equation around a little bit, right? Because if we were to rewrite this, C would equal B divided by 0.83, right? And then if we substitute into here, we get A equals 2241 times B plus B over 0.83. And then from here, we would probably want to jump into Desmos. So let me show you that first, and then I'll show you a pure Desmos route, which is pretty cool. So I'm just going to write that big old equation. All right. And to be clear, I'm not trying to solve anything. I'm just trying to wrap my head around this, because what we would want to do is we would want to distribute this 22 over 41 to this B and stuff. And an easy way to do that, because we're not dealing with any real numbers, at least not yet. So we could basically just treat B as 1, because we know that we're going to have some number multiplied by B equals A. So really, we just want to solve this out and change B to 1. So let's actually do that. On another line here, we could just have this, and then we could say that B equals 1. And sorry, I don't know why I have 22 over 41. It should be 22.41. That's what we had originally, 22.41. And now we're getting this number. So let's just wrap our heads around what it's saying. So if we were to rewrite it without all the stupid fractions, it would say A equals 49.41 B, right? So when it says what percent of B is A, B is this percent of A, 4941, which would be 4,941, or choice D. And this would be the traditional route. If you use the other route I'm about to show you, you're still going to need to know what's going on. You still have to have an understanding of percentages, but I'll show you something that's really cool here. So we could write all of this in Desmos. We could actually write the information in one line, because it's giving us information about A, and it's giving us information about B in the second equation, right? So we could say, we'd start a list, and we could say A, comma, B. So we know that these are our values, A and B. And then remember, for equals, we have to use a tilde whenever we're using constants and not X and Y. And then in our other list, since A is equal to 2,241 of B plus C, we could actually write that. We're going to say 2,241%. It's automatically going to say of, and then in parentheses, remember it was B plus C. And this is A, because remember, we have a list equal to a list. So basically the first component, A, is equal to all this stuff that I just typed. And then we want to say comma, because now we're saying what B is equal to, because there's a comma here. So just keep in mind, these lists kind of match up on the left and right sides. So we know this is what B is equal to, 83%. It's going to automatically say of, and then remember it was C. Cool. All right, so right now, it's not giving us any useful information because we don't have any real numbers. But remember, we want to relate what percent of B is A. What percent of B is A? So if we set B to a real number, and one that is easy to use with percentages like 100, for example, if B is 100%, A would be 4,941%. So this definitely takes being comfortable with understanding how percentages work. And basically by setting B as 100%, it's going to give us the actual percent that B would be of A. I know it seems kind of crazy. You could also think like B equals 1, then A equals 49.41. So now we're dealing with the number versions, but that's more or less how you'd want to set it up and get your whole answer just using Desmos. And again, remember, we're just saying if B equals 100, then what percent of B is A? It would be 4,941% of A, because if we multiplied by 49.41, we would get the value of A, right? So pretty cool stuff if you ask me. All right, last question. Pause the video and try it on your own first. But here we go. And so sorry if you wasted any time trying to use Desmos. It's not going to be very helpful for this one. And my tip for you is, in general, if you're dealing with a must type question, Desmos is probably going to get you into trouble because you're not actually solving for stuff. You're just trying to figure out logically what must be true based on certain conditions. So really, we can't be lazy on this. We need to try and match our sides up because we do have more or less, these equivalent expressions, and we just need to wrap our head around what's going on. So it's telling us that we have constants. So all of our constants are integers. And then we're trying to figure out what else has to be an integer, right? Now, it's not telling us if b is an integer or not. So I'm going to kind of ignore b to start. And hopefully we can get away with that. But instead, let's focus on h and j and k. So to get the left side, to get this and this to look like each other, our easiest route is going to be to simply FOIL this out. So let's do that. And I'm just going to rewrite this next to it so we can see them compared to each other. So we have 4x squared plus bx minus 45. And then that should be equal to, because it says it can be rewritten as, now I'm going to FOIL hx squared. And then we want to multiply hx plus j. So we'll have plus hxj plus kx, and then plus kj. Okay, now let's try and identify the most obvious things. First most obvious thing is that h equals 4, right? We have hx squared, 4x squared, so h equals 4. Just going to write that down as some helpful information here. All right, so say goodbye to these guys. We've extracted what we can from them. All the middle stuff would have to do with b. So remember, I'm ignoring that for now. And indeed, it's pretty ugly because basically all of this stuff would be equal to bx. Not super fun. But what is super fun is kj equals 45. So we're going to write that as well. Kj equals 45. All right. Now, with this information, let's see if we could eliminate anything. So the first thing says b divided by h. And again, I don't know anything about b. It's just telling us that b is a constant, and I don't want to deal with the middle right now. So I'm going to keep a. I'm also going to keep b because b involves b, and I don't know what's going on with b, so I'm just going to ignore it for now. C, 45 divided by h. Well, we know that h is 4, and 45 divided by 4 is not going to give us an integer, right? If we should just know that, but in case you didn't, you could throw it in real quick, right? 45 divided by 4, it's not an integer. And to be clear, an integer is a whole number. So I hope you knew that. So C, we know is not true. So definitely not C. That's good. What about D? 45 divided by K. Well, we can actually make that happen because we have this. 45 divided by K. And I'm sorry, guys. This should be negative 45. So we can kind of get 45 divided by k. We can get negative 45 divided by k, which would be equal to j if I move stuff around here, right? So if I divide both sides by k, then j is equal to negative 45 over k. And here's the deal. This is an integer. It says j is an integer. So we know that this, which is equal to j, is also an integer. And if we made it positive, that's not going to stop it from being an integer. So D must be true, which means it's our answer because we can only have one right answer. And even if we could prove that in some cases these two could be true, it's not about what could be true. It's about what must be true. So which of the following must be an integer? And our answer like that is choice D. Apart from being rated the highest difficulty on the SAT, those questions all had one thing in common. They all required deep problem solving and critical thinking skills. A lot of students feel shaky in those areas, and that's normal. Those skills aren't born, they're built. With the right guidance, anyone can strengthen them, and that's exactly what this video's sponsor, Brilliant, is designed to help you do. Brilliant is an interactive way to learn math, science, and logic that makes concepts click. Instead of sitting back while someone lectures at you, you're actively solving problems one step at a time. There's no endless cramming of notes or memorizing pages of equations. You just dive in, you follow your curiosity, and you let the lessons pull you along. The more you experiment with the ideas, the more they stick. I'm working through their visual algebra course right now, and I've got to say it completely reframes the way that you think about algebra. You know, the kind of math that makes up 70% of the SAT math section? You can start learning for free at brilliant.org/penguin test prep or click the link in the description. And if you enjoy the platform, that link also gets you 20% off a premium annual subscription, which includes unlimited daily access to everything Brilliant has to offer.